Guys, today we're going to do Unit 4, Lesson 1, which is the start of our unit on similar triangles, okay? The entire unit is going to use proportions and ratios, so I wanted to start our unit out by briefly talking about what they are and start getting accustomed to how to work with them, okay? So a ratio is a comparison of two different quantities, which you may remember from middle school. There's three ways that we can represent a ratio. It's with the two dots, with the word to, or with a fraction. Okay, we're going to be using fractions most often. So 3 to 1, 3 to 1, 3 to 1 is how we say that. A proportion is when you take two ratios and they are equal to one another. So two ratios that are equal to one another is going to be a proportion. To solve proportions, we're going to be using the cross product property. So the cross products are going to be equal. Okay, so let's talk about real quick the cross product property. 4 times 2 is going to equal, let's see, 8 times 4, right? And so if I cross multiply, I get 16, and then cross multiply the other parts of the ratio, and I get 4 times 4 is 16, and they are equal. Okay, so this was two ratios set equal to one another. So this is a proportion, and to solve the proportion, I had to cross multiply using the cross product property. So let's go ahead and just jump right in with our examples, all right? Example 1, write a ratio comparing the number of girls to the number of boys in a classroom. So there are 12 girls. 12 girls. Okay, and then the different ways that we can compare girls to boys is with those two dots, with the word to, or with a fraction. So I put girls first because the way that they said it was girls to boys. So boys come second. Okay, so 12 to 19, 12 to 19, or 12 over 19. So those are the three different ways that we can write our ratios. Okay, now up here I did give you the reminder of complementary angles are equal to 90 degrees. Supplementary angles are equal to 180 degrees. We're going to utilize that in these next two examples, okay? So the ratio of two complementary angles, so complementary tells me that I'm going to add two angles together and their sum is going to be 90 degrees. The ratio of these angles is 3 to 7. So here's how we're going to write that. We don't know what the angle measures are, but we're going to use the ratio. So 3 to 7. And that should be a 7. And we're using X here because we don't know, like the side lengths themselves are not 3 and 7, but that is the ratio that compares the two sides to each other, or two angles to one another. So now we're ready to solve and find out what are the angle measures. So 3x and 7x is 10x. Divide by 10, x equals 9. Okay, so now how do we find the measures of both of the angles? Well, we've got our ratio is 3 to 7. Okay, replace the x with 9. So 9 times 3 is 27. And we're talking about an angle measure, so let's put our degree symbol. And then 7 times 9 is going to give me 63. 63 degrees. So those are my two angle measures. All right. Let's do the same thing with the next example. Example 4. The ratio of two supplementary angles. Remember, supplementary, the note at the top was 180 degrees. So we're going to take two supplementary angles, add them together, and they're going to equal 180 degrees. The ratio here is 4 to 1. So 4x plus, you can put 1x or just x. It's up to you. Let's go ahead and solve for x. 5x equals 180. Divide by 5. And x is going to equal 36. So in this situation, they wanted me to find the larger angle only. So the larger angle was 4 times x, so 4 times 36, and that larger angle is 144 degrees. Okay, that's just the larger angle that we found. Let's look at example 4. The ratio of the measures, let me bring this down a little. Okay, the ratio of the measures of the angles in a triangle is 3 to 7 to 9. Find the measure of the smallest angle. I want you to remember that the 3 measures of every triangle add up to equal 180 degrees. That is our triangle sum theorem, okay? So let's go ahead and set up our equation. 3x plus 7x plus 9x. Let me use a darker blue. 9x equals 180. So I'm going to add all of these together, and I get 3 and 7 is 10, plus 9 more is 19x. 180 divided by 19 is going to give me 9.47. Okay, 9.47. Now, in this problem, they wanted me to specifically find the smallest angle. So it's going to be the one with the smallest part of the ratio. So 3 times 9.47 gives me 28.4 degrees. 28.4 degrees, okay? And then, of course, I could have found any of them just by plugging it into the correct place. Let's do one that is still dealing with triangles, but instead of dealing with the angle measures, we're going to talk about side lengths and what can you do in this situation. So the ratio of the measures of the sides of a triangle, well, we're still going to set this up the same way. 2x, 8x, and 9x. Okay. This tells me that the perimeter is 76 degrees. I'm sorry, inches. So how do you find the perimeter of a figure? Well, you add up all the sides of the figure, and that's how you get the total measure of the perimeter. So I have set up my equation. I'm ready to solve. So this is going to give me 2 and 8 and 9 is going to give me 19 again. 76 divided by 19 is 4. It's 4. And in this case, they want me to find the length of each side of this triangle. So we can do that by doing 2. So I'm remembering my ratios. 8 and 9. And then I need to just multiply each of those by 4. 2 times 4 is 8. 8 times 4 is 32. 9 times 4 is 36. Okay, and if you add them all up, 30 and 30 is 60. 8 and 2 gives me 70, and then 6, 76. So it works out. It does add up to 76. And these were the 3 sides. Okay. All right, let's transition over into talking about proportions, and using the cross product property. So in our little mini example up at the top, I had all numbers there. In this situation, I'm missing one of my numbers. So we are going to use the cross product property, 2 times x, and that is going to equal 4 times 7, which is 28. And then I can solve for x. So divide both sides by 2, and we get x equals 14. Okay? So 4 over 14 is the same as 2 over 7, which is true. 4 over 14, if you just divide both by 2, it will equal 2 over 7. Okay, great job. Let's go take a look at example 7. So I'm just going to scooch this up a little in case anyone is missing those. Okay. Solve the proportion again using the cross product property. So same situation. Let's go ahead and cross multiply these. Okay, cross multiply. I get 18 times, now because there's 2 terms here, I want to be certain that I use parentheses, okay? 3x plus 4, and that is going to equal 12 times 15. 12 times 15 is 180. Okay? All right. Now, let's go ahead. So you've got 2 ways that you can go about this. You can either do your distributive property if you'd like, or we can just divide by 18 on both sides so that this is by itself. So I'm going to go ahead and divide by 18. So these cancel. 180 divided by 18 is 10. And then let's just finish solving this normal equation. Subtract 4 from both sides, and then divide by 3. And so x equals 2 in this case. X equals 2. All right, let's do our last example of just solving a basic proportion. Okay. I'm going to again demonstrate using my cross product property. So 7 times 8x minus 7 is going to be equal to 11 times 4x plus 1. This time I'm going to solve this by showing distributive property, okay? So my distributive property here, 7 times 8 is 56. 7 times 7 is 49. 11 times 4 is 44. And 11 times 1 is 11. And now I can begin to solve this through. So let's subtract our 44x's and move all those to the left. And I get 12x minus 49 equals 11. Let's add 49 to both sides. I get 12x equals 60. And of course, 60 divided by 12 is 5. Okay? If you would like to just prove by plugging in that these proportions are indeed equal to one another, it would be really easy to do. All you'd have to do is plug in right here. So 4x plus 1 over 7. Instead of x, you put a 5. And that's going to equal 21 over 7, which is the same as 3 over 1, okay? And then you can do the same thing here. 8 times 5 minus 7 over 11. That equals, let's see, 40 minus 7 is 33 over 11, which is the same as 3 over 1. So they are indeed equal to one another. Okay, they both reduce to 3 over 1 is our ratio. All right, this is going to be something brand new that we have not discussed prior to this lesson. Okay, the triangle mid-segment theorem. Here's what it says. It says if I have a segment in the middle of my triangle that connects the midpoint of this side and the midpoint of this side. Now, how can I tell for sure by looking at this that D is the midpoint of AB? Because these tally marks, remember what we learned about congruencies in triangles and how we label those congruencies. Congruent means that they're equal. So this is the same as this, their lengths, which means that D is the midpoint here. Now I've got these two little tallies, which means that these are congruent to one another, which makes E the midpoint of this side, BC. Okay, so if you have these two midpoints that are connected, this is called the mid-segment. Mid-segment. Then what you know for sure is that the mid-segment is parallel to the third side of the triangle. And the mid-segment is half as long as the third side. Okay, so I have written our proportion over here for us. The mid-segment, DE, over the third side, AC, is equal to 1 over 2, 1/2, okay? So another way that you could also say this or think about it is that AC is twice as long as DE, okay? So let's jump right in with example 9 and talk about and think about how we're going to use this proportion to solve problems. Okay, so example 9, we need to find the value of x. So I'm going to go ahead and set up my ratio here. Let's see. This is the third side of my triangle. Okay. The third side of my triangle is 19x minus 36. The mid-segments is 6x plus 31. Okay. And so that ratio is equal to 1/2. All right. So we've set them up. Now let's go ahead and cross multiply. Let's cross multiply. So I'm going to get 1 times 19x minus 36. So just 19x minus 36. And that is going to equal 2 times 6x plus 31. Okay. All right, now we have a regular equation to solve. Let's do our distributive property. 2 times 6 is 12. 2 times 31 is 62. Okay, and now let's move all of my x's. I'm going to move them to the left so that they'll stay positive. So subtract 12x. That gives me a 7x. Let's add 36 to both sides. And that gives me 98. And 98 divided by 7 is 14. So I found the value of x. Found the value of x. Now, what would you do if they asked you, what is the length of the mid segment, or what is the length of the third side? So let's just talk about that real quick. If I want to find the length of the mid segment, I would just plug that in. Okay, plug in 14. So 6 times 14 plus 31 is 115. I just typed it in my calculator. Okay. What about the third side? That is 19 times 14 minus 36. And that equals 230. 230. Okay. So you can see that this is 1 to 2, because if I multiply 115 times 2, I get 230. So if they ask you for the length of either side, you just plug the value of x in, okay? Let's do example 10. They want me to specifically just find the length of RT, okay? So let's set up my ratio. My ratio is going to be my mid-segment, 15x minus 17, and that's 1/2, to my third side, which is 23x minus 6. I'm going to go ahead and cross multiply. So 1 times 23x minus 6, 2 times 15x minus 17. Do my distributive property. 30x minus, let's see, 7 times 2 is 34. Okay, this time I'm going to move the 23x to the left so it'll stay positive. I get 7x. Let's add 34 to both sides. And I get 28. So divide by 7, x equals 4. X equals 4. So I need to plug that in here. now I know x equals 4, okay? So 23 times 4 minus 6. 23 times 4 is 92. 92 minus 6 is 86. Okay, 86. Now, if for some reason I wanted to know the length of the mid-segment, I could actually do it two ways from here. I could either plug in 4 for x and simplify again, or now that I know the length of the third side, I could say divide that by 2, and that's the length of the mid-segment. It would be 43. 43, okay? And you could actually just double check and verify that if you wanted to, that it's 43. So 15 times 4 is 60. 60 minus 17 is 43. So it checks out, okay? So this is just the work for me plugging in 4 for x here. But you could have also just said 86 divided by 2 is 43. Okay? All right, here's our very last example for today. They give me 3 sides of a triangle, and they want me to find the perimeter. So let's just make a note that our last step, because they want me to find perimeter, is to add all the sides. Okay? So I'm going to have 3 side lengths, and I'm going to need to add them all up. This is going to be the last step of solving this problem. The first step. So you know how I told you here you could divide the 86, the third side measure, by 2 to get the midpoint? Well, you can do the opposite here. So they tell you that MN right here is a mid-segment, which means that the third side of the triangle opposite that is going to be double the length. So 49 times 2 is actually 98. So that side length is 98. So I found one side already. Let's find the other side. NO, I'll use green. NO is right here. And so the side opposite NO is midpoint M. So I'm going to have 42 times 2, and 42 times 2 is 84. So 84 goes there. Well, I'm almost done. I've got 2 sides of my triangle. Now what I need to do is set up my ratio, okay? For this last side here, I have 2 variables. I don't have a solid number, so I'm going to need to set this up using my ratio or my proportion, okay? So the mid-segment, 6x minus 1, that's the mid-segment, over the third side, so don't forget which one goes on top and which one goes on bottom, is equal to 1/2, okay? So let's go ahead and cross multiply. 2 times 6x minus 1 equals 1 times 13x minus 10. Okay, I hadn't written that before. You don't have to. I just did. Okay, and so now I've got 12x minus 2 equals 13x minus 10. Let's move the 12x's to the right. so it stays positive. -2 equals x minus 10. Add 10 to both sides. X equals 8. X equals 8. So I need to find the third side of this triangle. 13x minus 10. Now I know x is 8. Okay. 13 times 8 minus 10 is 94. So this side equals 94. And I showed the work for it right here. Whoops. Okay. And so let's go ahead and add this 94 over here. And so 98 plus 84 plus 94 gives me 276. 276 is the perimeter of triangle JKL. And that's my final answer in the bottom right corner. Okay, guys, so that is our whole lesson for today. There is a practice assignment posted for you. Hopefully you'll find this to be a pretty easy practice. All right, just let me know if you have any questions. Until next time.